Good afternoon for all of you. I hope you are fine, you and your family. Please stay at home and be careful. Today, inshallah, we will start to complete the lessons we start in the class. We will move on the syllabus. With you, Mr. Mostafa Ibrahim from Tabarak Private School.
We stopped in the last lesson at how to know the order of reaction from the graph. See with me, and on the graphs on the left you have the relation between concentration within time. So we know that concentration of any reactant, it must be decreased within time. So now if you see zero order reaction, you will find it straight line. It decreases but regularly. But in first and second order, first order which is in blue and second order in green, you will see that the first order and the second order reaction both are curves, but the difference between them that the second order reaction is more steeper than the first order reaction. Now on the graphs on the right you will find the relation between rate and concentration. We said if we increase the concentration of any zero order reaction, the rate will be constant, no change on the rate. But in the first order reaction, if we change the concentration, the rate also will increase directly proportional. If we double the concentration of reactant, you will find the rate also is doubled. If we decrease the reactant its concentration to half, the rate also will decrease to half. So the rate with concentration, you will find it directly proportional and irregularly. Like the first order reaction, it will be straight line which is in blue. See the second order reaction also, it is directly, but it is the increasement is irregularly. How? As if we increase the concentration of reactant is doubled, what will happen to the concentration or to the rate of reaction? The rate will be increased 4 times. So you will see that the relation between rate and the concentration for a second order reaction, it will be curve. After that we stopped also in the last lesson half-life. What is meant by half-life of a reactant? We know that the concentration of any reactant must be decreased within time. So for example, if I start a reaction with concentration 8, how can I know the half-life from a concentration time graph? For example, if I said we start with 8, at 4 we can know the half-life from the graph. So the half-life can be calculated from a graph. How? From the initial concentration, we divide it by 2, we get the value, for example like 8, so divide by 2, 4. At 4 you can calculate the half-life. After that, if you want to calculate another half-life, we said we start by 8 divided by 2, 4, then 4 divided by 2, 2. So you can calculate another half-life. And we said from the half-life you can know the order of reaction. If the half-life decreases, it is zero order. If it is constant value, it is first order. If it increases, it will be second order. This is a quick revision for what we take in the last lesson. After that, we have a special rule for the first order reaction. For any first order reaction, we have a relation between K and T half. What is T half? We said before, T half is the half-life. What is K? K the rate constant. Remember with me, what is the factor can change the value of rate constant of a reaction? Only one factor. It is what? I hear you. What? Temperature. Yes, excellent. Yes, the factor that only can change the value of rate constant is the temperature. So now this relation T half equals 0.693 divided by K. 0.693, it is constant in the rule. So we have only T half and K. If we rewrite it in another form, we can write that K equals 0.693 divided by T half. So but take care, this rule only can be used with a first order reaction. We cannot use this for zero order or second order or any other order of reaction. Now we will talk about two important questions in the last year final exam. In the final exam of last year, we have two questions, one of them related to this rule and another one related to the rate equation generally. So let's see the first example. The first example, read carefully with me. Ethyl chloride, it doesn't matter what ethyl chloride, propane, hexane, ethanol, ethanoic acid, it doesn't matter. I concentrate on the given information to me. Ethyl chloride decomposes into ethylene and hydrochloric acid in a first order reaction. So what is written now? In a first order reaction. So we can use the rule K equals 0.693 divided by T half. Let's complete. That has a half-life of 120 hours at 650 degrees Celsius. So why we say the temperature in this question? Because we know before few minutes that the temperature can change the value of rate constant. So when we ask to calculate the rate constant for the reaction under these conditions, he want to say that the temperature is constant, so the value of rate constant will be the same, no change in the rate constant. So now if we concentrate again, we have now half-life. We have the value of half-life. It is given to me 120 hours, and we have second. We want to calculate the rate constant in second -1. So now, because this is a first order reaction, so we can use the rule K equals 0.693 divided by T half. We said 0.693, this constant in the rule, divided by, what is the value of T half? T half 120, but it is in hours, so we must convert it from hours to seconds, because we need to calculate rate constant in what? In second to the power -1. So now, how to convert? Remember to convert from minutes to seconds times 60. To convert from hours to seconds times 60 times 60. So you can direct times 3600. So now K 0.693 divided by 120 times 3600 to do what? To convert from hours to second. You get now the value of K 1.6 times 10 to the power -6 in second -1. So this question in the final exam of last year. So another question also in the last year exam. Let's read the question and concentrate on the given information and numbers. Now we have in this question, you can check, you have the final year exam with you on model, you can check the question. So Now the reaction between x and y was studied. X plus y gives xy. By doing two experiments at the same temperature, see why it is written here at the same temperature, to tell you that the rate constant is the same in experiment 1 and experiment 2. It is found that the rate equation, rate equals K times concentration of X and concentration of Y. Now we want to use this rate equation and the information in the table to answer some questions. So firstly, check what is provided in the table. The information, we have two experiments. We have the concentration of X in experiment 1 and experiment 2, concentration of Y we have only in experiment 1, but in experiment 2 it is unknown, and the rate is provided in the two experiments. So firstly, we asked you two theoretical questions. Number 1, what is meant by half-life of a reaction? We said it before few minutes, to the concentration of a reactant to decrease or to fall to half of its original value, to half of its initial concentration, initial value. So you can change some words, but don't forget the keywords. Time for concentration to be half of its original value. So this letter A was meant by half-life of a reaction. It is the time taken for the concentration of a reactant to fall or to decrease to half of its original value. After that, another question, this from basics. We want to ask about two factors, state two factors which can affect the rate of a reaction. We have many factors that can affect the rate of the reaction. For example, we take in this chapter that concentration can change the rate of the reaction, also temperature, the catalyst in grade 11. What is catalyst? Catalyst, chemical substance that speeds up the reaction. So the catalyst also can change the rate of the reaction. Also in some reactions, light and surface area and the nature of the reactants. Only we need two factors. Any two factors are written, you will get the mark of the question. So this letter A and letter B, I think like a gift, was meant by half-life and two factors. After that, the most important part in this question, let's go back again to the question. In letter C, we want to calculate the concentration of Y in experiment 2. Think with me. Look to the rate equation. Look here to the rate equation. Rate equals K times X and Y. Concentration of X and concentration of Y. So if we want to calculate Y, we must have the values of rate, K, and the concentration of X. If you check experiment 2, you will find the rate value with you and the concentration of X also with you, but we have another unknown, which is K. We have rate, we have X, but we don't have the value of K. So as I said before, it is written in the beginning of the question at the same temperature. This indicates to what? That the K is constant for the two experiments. So if you calculate K from experiment 1, you can use it in experiment 2. So the first step, we calculate K from experiment 1. How can we calculate K? K equals rate divided by X and Y. You have all the values. You have rate, you have concentration of X, and you have concentration also of Y. After you find K from experiment 1, you can use it also in experiment 2 as the same temperature, as the temperature is the same. So now let's see the solution. If we said step 1 we do what? We say from experiment 1 we must calculate K. So K is the subject, rate divided by concentration of X and concentration of Y. So rate equals 1.35 times 10 to the power negative 7 divided by 0.1 times 0.005. From where these values? From the table. These values, which is 1.35 times 10 to the power negative 7, 0.1, 0.005, we use them to calculate K here. So we get the value of K, 0.27 times 10 to the power negative 3 mole to the power negative 1 dm positive 3 second negative 1. This, remember, the measuring unit of K from a second order reaction. Who can remember me what is the measuring unit of K in a zero order reaction? Like the rate, mole, dm negative 3, second negative 1. This for zero order. For a first order reaction, K is measured in what? Second negative 1 only. And for a second order reaction, it is measured in mole negative 1, dm positive 3, and second negative 1. So after we calculate K from experiment 1, we can substitute its value in experiment 2. If you see now in experiment 2, you have the value of rate from the table. K you calculated from step 1. X is provided also in the table. So the unknown will be only what? Y. So Y is calculated by 5.4 times 10 to the power negative 7 divided by 0.27 times 10 to the power negative 3 times 0.2. Now you get the value of Y, 0.01 mole dm to the power negative 3. So this, by these two questions, we finished the syllabus in chapter 2. Inshallah, in the next video we will start to explain the introduction in chapter 3. Talks about the equilibrium.
I hope you are enjoy the listening and you understand the topic we explained today. We appreciate the efforts of Mr. Yunus Rahbi, the chairman of Tabarak Private Schools Group. And don't forget, your homework is uploaded on model on Tabarak Private School site. Thank you and goodbye.